afternoon, ladies and gentlemen, I'm John, this is Many a True Letter. Welcome to Wild True, learn, open brackets, close brackets, or however you pronounce that title, I'm not sure. This is a puzzle game which claims to basically be a simulator of machine learning and visual programming where you help a guy and his cat do the above. So yeah, I'm on board for all of this. So let's get into some visual programming and or machine learning. I'm not exactly sure how you define any of these terms. Basically, what happens in this puzzle game is, over on the left, there's a bunch of stuff that's about to be spat out. So, 10 red squares, 10 green squares, 10 blue squares. They're going to be spat out. Over here, the client wants to receive only red squares. So I've got to link together logic gates in order to make that happen. Now that initially seems like it should be relatively simple, because over here I've got two different types of logic gates. One that makes a decision based on two colours that you input, and one where you pick one colour and say anything else gets filtered out. So probably we want to go for red versus else, say plug the input into here. If it is red, it gets fed over here, and trash can goes over to here. So that looks like it should basically work. Give that a test, however, and we're going to run into a bit of a problem, which is we've got a time limit up here from the client. And while this system is technically the easiest way to do this, it's a little bit on the slow side. The system can't deal with these blocks fast enough. So as a result, time's about to run out and I have failed. So instead, I need to come up with something a little bit more complicated because I need to make sure that my system actually works alongside all the different criteria. So instead, what we need to do is, feed them into here and say, if red, then you can proceed straight onwards. However, if you are, it can't be any, otherwise, like, some of the reds will be filtered over there too. If green, you come down to wait. Can green go over to... Green goes... No, hang on. Green needs to... Wait, no, I'm already lost. No, I've got it, because green can go straight to the trash can. However, this means that blue is going to get divided between these two because there's nowhere else for blue to go. So half of blue will follow the green line down to the trash can, which means, get rid of this line, I just need a second decision tree over here that leads up to red or blue, because then any blues that escape the first time will get caught there, and then the only thing coming out of here should be reds. And because this thing's making its decision in 0.3 seconds, because it's got more specific instructions, that should be a lot faster. So give it a test run, and things just basically get sent through here, and you'll see that the blobs are going through a lot faster. And either the blues getting filtered out here, or the blues that make it over to here are being spat out over here. Only the reds are making it through. Flipping marvellous. Well done, me. And a little bit like Opus Magnum, you kind of have to do it as efficiently as possible, because, the faster you can do it, because the servers cost $2 a second, and you're receiving a fixed reward, the faster you can get the operation done, the more money you get for yourself. So let's see if I can just ever so slightly optimize this by actually having it a bit more straight-liney, so, the data doesn't need to go all the way over here or anything. So, release that. Except that I'm actually buying servers for this. So my money is ticking down because I have to rent the servers to actually do this work. And all the data is just swishing through. Lovely, lovely, lovely. Hopefully that will be done soon. In goes the last bit of data. I think that was actually slightly cheaper. I think it was $29 a second ago. So I have indeed managed to save $1. Beautiful. And as well as colours, shapes are also options. So I'm going to guess this is going to start getting very, very complicated indeed once we get into a world where shapes and colours start getting involved, yes. So we've got a new type of logic thing here, and also I believe this game is trying to teach me about the real history of visual programming. Because it actually says, for each of the different gates, it actually says, in the real world, this was apparently Rosenblatt's perceptron used in Mark 1. Perceptron could recognise only simple linear dependencies, but it was enough to recognise English letters. So that's just lovely. The problem is, while this looks like this should be simple, I think we've got an issue with, the accuracy. This thing is not 100% accurate because it's trying to recognise letters officially, but I suspect we're going to run into some trouble. Okay, well, let's just see what the base accuracy it spits out is. It looks like they're looking for 75% accuracy, and this thing Hopefully it makes an error 25% of the time, in which case maybe this is just about good enough. So give it a test run and see what happens as a result. But yeah, it's going to be hit and miss whether this actually works or not, isn't it? Yes, potentially. Okay, you know what? I've got a better plan. Get rid of all of this, because I'm not charged more for using more of these, I think. So why not have a second security layer built in as well? So we believe that what should happen is, yeah, we want the triangles and the circles to be going up this way, and then if you're certain that's a triangle or a circle, then feed it into here. Squares get brought down here, and then if you're certain it's a square, it goes down over here, whereas the triangles and the circles, they get missifted, move over here, and any squares that get caught in the second pass move down to here. Now that should make the system a lot more accurate, albeit presumably it's also going to... Will it slow down though? Because the times are exactly the same, so it won't bottleneck. Because, in fact, actually, these two can't bottleneck because they're actually servicing... Well, this one should service... The numbers are the same. Yeah, it's 300 each. This one's servicing twice as much. So this one's servicing 2/3 of what this one's servicing. So there shouldn't be a bottleneck. This shouldn't slow it down at all, aside from the fact the path's a bit longer. Give it a test run and see if that immediately generates much better accuracy. Because that's what it should do. Because logically, like, oh. Okay. Why is this one making more mistakes? Okay. I ran out of time. Okay. Maybe I'm overcomplicating this. Because this thing's making an error only 20% of the time. This thing's making an error 34% of the time. This thing's making way more errors. Okay, why don't I just shove this one out of the way, shove this down here, and now keep an eye on the timing to see what happens next, because these bars need to fill up in time, so I just need to get the squares in faster, because this thing, that is the problem. The squares need to be got in faster, because there's not enough squares to actually fill it up. Oh, no, I ran out of time. I need to get the squares in there faster. Is that actually right, by the way? Yeah, that's right. It's just, it looks a bit odd, because it's kind of got a bit stuck behind the other one. Okay. How am I going to get the squares in here faster than... Oh, this has allowed triangles too. Oh. Well, that's... Okay. That's of interest. Well, in that case... Oh, how do I get... Okay, how do I get additional triangles down here as well? Ooh, hang on. No. Okay, back to plan A. Back to plan A. Now I know what I'm doing. So the square thing goes down here, but some triangles will be brought down here. So in which case, that then moves over to here. We don't put a second pass on for squares coming out of the top perceptron. And now, any triangles that get misdirected down here, albeit that's only 20% of them, that should logically make things better. Right, and also, I just saw a flipping square come up here. Stop sending squares up here. This is not where they should be. So right now it's just squares, but the odd triangle ought to come down here as well. Right? No. Okay, I think I need to rethink this from the start. Okay, what if I redirect the triangles from here down to here? Then this one might not fill up enough. I think I'm just basically reversing the problem. I've got the same problem going on. And now also that's... A bunch of squares just went up there somehow, which they shouldn't do. But it feels like, actually, for some reason the circles are... Why are the circles coming out... I don't know why the circles felt like they were coming out faster, but screw it, this does seem to work, yes, so let's get that underway. Oh, wait. Because up here, it only requires 18. That's why. Okay, this is all a valuable lesson in how to read things. But it's fine, because now I understand, so going forwards, I will know what I'm doing. I'm increasingly suspicious this game is actually trying to educate me while I play. So, let's have a look, see what we've got going on here. I am being fed 10 red squares, and yeah, they're all squares, so I didn't bother mentioning the squares. So 10 red, 30 green, and 10 blue. Now we need to get 8 down here and 9 up here, where down here only the green will do, whereas up here anything will do. Okay, that strikes me as doable. So obviously in that case, we'd want to get the green going down in this direction, because the green must be going over there. That means the red will go up. Oh, no. That means the red will go up here. Just get this. I think we're going to need a split tree again, because then the red will definitely go... The red will go up. Does the red need another one? I don't think the red needs another one, because the red's just going straight on its way. And then the blue and... Yeah, the blue will be divided between these two. So blue might be coming down over here. So in which case, green can just carry on its merry way over here, whereas blue can travel up here. Now that means that all of the red and all of the blue are going this way. And I don't have a way of saying send... Ooh. Yes, I do. I exactly... Wait, hang on. I do have a way of... Yes, no. I do have a way of splitting the green. I can split the green. No, go back to drawing board here. Because if I am put over here, then what's going to happen now is the red is going to go this way and the blue's going to go this way. And the green will be evenly divided between both of them. So now, as a result, the red and half of the green are going to go over here, because the green is so much more numerous. We do need some green going up here, because this needs to be done fast. So now, coming out of the blue is the blue and half of the green. So in the event that it is blue, then it needs to go up here, and in the event that it's green, it comes down here. So that means that, yeah, 15 of these greens should be committed down here, and 15 of the greens are going up here together with the... Okay, that was a bit unfair, really. That kind of unfairly skews against everyone. Possibly my original plan was better, but I'll give this a test run to see if enough greens make it down in time. And they do. It actually just works. I'm not sure whether that's necessarily the most efficient way to do it, but it does seem to be working, so I am going to accept that and send it on its merry way. Because, yeah, there's loads headed over here, and the bottom one just makes it in time. So I will take that. Right, we've got a new thing being introduced, a load balancer. So that distributes network or application traffic across a cluster of servers. So within the game, that basically just says, it just splits them. It just sends it into whichever has less queue, if you like. Got it. So, in the case of this little tutorial, yeah, you just split and everything's lovely, gotcha. So, 80 reds and also some greens and blues, and you just want the reds. So I'm going to work under the assumption that this is not going to be fast enough. And if I just bring a trash can out here and bring everything down here, this is going to be nowhere near fast enough. But the test run will let me know how nowhere near fast enough it is. So that gets over to... Time has run out, and we've only got to, like, yeah, maybe 25% of what was required. Yeah, 9 out of 30. So I need 4 times what we're actually doing right now. Get that out of the way for the time being, get you out of the way. So I can use the load balancer, and I probably want 3 of them in order to start splitting the traffic into 4 separate queues, so I can have 4 expert systems running simultaneously to speed up the process, and 1 trash can to catch everything else. So you can just head to here, you guys hook into here, and yeah, we are indeed wanting to filter to red, so all 4 top options feed into that, and all 4 bottom options feed into the trash can. Give that a test, see if that's a lot. Oh, that's... Okay, that's quite pretty. That's quite pretty, and I approve of that. And I actually ran out of time. Well, that's fine, because there's no reason for it to necessarily be, like, balanced at the top and the bottom. If I just bring these down a little bit and introduce, like, a further 2 at the top here, this one just gets broken up into a further 2 here. That's fine. This is probably a bit too much, to be honest, but give that a go, because it's now technically in balance, but Oh, I've created a massive backlog there, but it looks like it should still be... No, it's because I've managed to create a backlog right here, because now... hang on. Test run, but test run it a bit more slowly. So the problem is, I think I literally clog up the server here. And also, why isn't that any faster? No, there's a bigger problem here. Why was that not faster? Surely it should have been faster. That's odd. Wait, hang on, try rewiring this, because I think actually this one wasn't wired into anything. Now that you're there, and now there's... Wait, how has that turned out to be... Because there's now two up... Hang on, let's just make sure they're actually all lined up so I can see what's what. Okay, hang on. Give that a test. See if that works a bit better here. And now... No, now there's just a queue going on in this direction. Well, there's always a queue going on in this direction. I think that is actually working a bit... Okay, fine. That does work faster. I was just trying to think, hang on. Is there a reason why something's bottlenecking here? You know what? That'll do. That's fine. It's a bit on the expensive side, mind. I'm paying for a lot of servers here. So the extra servers are costing me money. So possibly redundant servers are not a good idea. But screw it, it'll do. Now, on this occasion... This company wants just red squares being pushed through as quickly as possible. So I'm going to actually, have reds being pushed through. And the option is going to be red or other. Now that means that some reds will actually get caught up in any. But hopefully this is enough servers and decision tree for colours that actually... it'll work regardless. So you got split. And then... yeah, the reds go in there. Yep, that's fine. Good. That is good enough. So even though some reds got thrown in the bin, enough went through it was still efficient. So that I'm actually pretty happy with. Okay, now we're into interesting territory. So I've got a few blues, twice as many greens as blues, and twice as many reds as greens. They need to head over to the right-hand side, where on the top, only reds and greens are acceptable, and 15 need to be delivered, whereas down bottom, reds and blues are acceptable, but that requires 30 to make it through. So my instinct would be, all the reds just basically come down here, all the greens come up here, and we actually say screw the blues, in order to keep things as simple as possible. So let's just see how far off we are if I don't bother doing any load balancing whatsoever. So this comes into here. Greens go up. Reds go down. And then actually we also need to filter out the blues because 100% accuracy is required. So we need at the bare minimum a second decision tree colour here and a trash can in the centre. So this is green versus blue, and this is red versus blue. Then we just hook that into you, that into you, that into you, that into you, and then the blues get trashed. Now let's give that a test run to see how slow it is, and how far off I am. So accuracy is going to be fine, and they are filling up at roughly the same rate, which makes me think I'm onto, basically, a good idea here. The problem is, I now need to duplicate this once. Because if I just duplicate the first stage, it'll bottleneck on the second. So I need to pull these down over here. This needs to get brought down to here. This needs to get cancelled. I need to bring one load balancer in over here. And then I need to create a cloned version of what I have below above. And that should, at that point, work. Probably. Alright, so if I've got this all right here, this should now basically be the same process, but twice as fast, so it will easily get the amount of required data in time. So that one's done. Job done. Success. Nice. It's very pretty as well. I quite like the prettiness of all the data just basically flying around. That's very visually pleasing, and just binning the blues was definitely the right thing to do. That keeps things a lot simpler and keeps the costs down. Now, what I've been doing so far is just one-off jobs, but there's another thing as well. Startups apparently want my attention. Some students want to build a self-driving car. I cannot possibly see how that would go wrong. Our algorithm makes a lot of errors when it tries to recognize traffic light signals. As a result, the car sometimes moves on stop signals. We need to solve the problem. That does sound like a big problem, yes. So, right, what do I want to do? I'm choosing to invest in this thing while I'm getting involved. Okay, well, I'm sitting on a giant pile of money right now, so why don't I spend $400 on 400 shares, join the startup, fix it, and then the shares will be worth more? That logically makes sense. Oh, startups, as it turns out, are more complicated. Right, okay. So, what am I going to do now? What I need to do is, with 100% accuracy, we've got to be able to tell the difference between a red circle and a green circle. But apparently a whole bunch of other data will be inputted, because, like, other signs will be on the road too. Okay, this is fine. So. Let's work through this here. First things first, let's actually make sure only the circles are getting through. So circles need to come through. But, okay, hang on. Sift is relatively slow because it's a complicated process. And decision trees are fast. Okay, if I was to have... No, let's think about this sensibly. Let's future-proof this a little bit. If I actually immediately load balance times 4... up front, no, hang on, no, just times 3, because 3 is enough to get you 4, so to you, and then you guys come over here, then I've got 4 tracks simultaneously. Then I can do 4 sets of sifting, and that means we will know straight away on this side that we've only got, oh, I'm going to run out of space. Okay, what I'm going to do because of that is, this is all going to happen over here. Okay, this is all going to happen over here. The sifting is going to go on over here. Everything's going to be fine. So that's going to be load balanced. And then the load balancers are going to feed into 4 simultaneous sift procedures that are going to say we only want circles and everything else is going to go into the trash can. So to you, to you, to you, and to you. So the 4 top options are producing nothing but circles. And they should be producing at a rate of roughly 0.3 seconds per thing being outputted. And that's 0.3 across 4 processors. Which means if I have 4 decision tree color stages, then that would actually work pretty well, presumably. Because each one should be able to receive at roughly the same rate as the sift is outputting. Now what we need to do immediately is... every single one of these can go, green or... yeah. If we immediately red and green, if we go through a 2-stage process here, they all red and green, that's all fine. And then beyond that, the blues will be divided up between them. So there will be blues mixed in to all of this. That's fine. Then I just need a second tier. I'll put a new trash can in so it doesn't get too confusing. That then will feed into a final check, which is how we're going to filter out the blues. And we don't want to use the expert system because that's too slow. I'd rather use additional decision trees based on colour. So the red and the green can... hang on. That's now outputting... I'm going to need 8 of them. Otherwise it's going to slow to a crawl and this is going to be the bottleneck. Yes it is. So we're going to need... oh blimey. Okay, just everyone just shuffle up and make friends. Right, I'm actually going to have 2 trash cans so I can keep an eye on the lines a bit better. So what we have here is... every single one of these is outputting red, then green. So all the bottom ones here need to be blue. The important thing is the bottom one's always blue, so I know that the bottom option is always being binned. That's absolutely fine. And then it just matches up to whatever the nearest option is. So red, green, and that just alternates. Red and green, and red and green. And that's all absolutely fine. So then I just feed each of these into the relevant option, right? That's right, red into red, green into green, red into red, green into green. Right. And then all the ones that are marked as red need to go to red. So you go over here and you go over here and... oh, this is going to be difficult to read. Okay. And then all the ones that are marked as green go over to green. But only ever the top option of a green. And then a blue, i.e. the bottom option, must always go to a bin. It must never go to anything that's not a bin. Okay, now what I'm going to do is I'm just going to shuffle this back a little bit so I can make all of these actually be a little bit like, you know, more this way. Because otherwise the lines are going to get confusing. And that's going to be a lot easier for me to read and interpret what's going on if it's a bit more in this direction. And this is... this doesn't look efficient, but it's not actually more expensive. So I think it's fine, actually. Right, give that a test run and see what happens as a result. So data starts getting skewed out and then... oh. Okay. So the problem is the weight. Just because there's 4 sifts, John, doesn't mean they're all outputting at 0.3. It means one is being produced at 0... oh. Right. Okay. No, it's fine. It's fine. I've got an idea for how to fix this. Because what I actually need is a lot more sift. Like, I need huge amounts more sift. Except, is there a more efficient way to sift? Because sift, I believe, is the only option I've got for... wait, can an expert system do a colour? No, expert system is just for colours. That does not do anything else. The only way to filter to round is the sift option. Okay? I'd like to take this opportunity to apologise to anyone who actually works in, like, tech or programming or visual programming or machine learning. Because at this point, you've probably just seen this and you might have just basically dropped dead immediately. But I think it should work. What I've got here is a lot more load balancers. And that's going to feed a lot of data into a set of 16 sifters. 16 sifters serving 4 actual trees of decision tree color logic gates. Which should mean the data actually gets fed through at the right rate. So let's actually test this at this point. And now data is... it's flying around in the background. And then starts getting sifted around there. Then it starts getting fed into the various different sift engines. Okay, and the sift engines start flinging... yeah, that looks like a whole bunch of triangles and squares flying into the trash can. And what's going on as a result of that is... okay, this does technically appear to be a series of correct results. The question is it actually producing enough data... and good stuff to... oh, everything's really backed up right now. Everything's... oh, hang on. Why is this one not doing anything? What should this one be hooked into? Should this one be hooked into... how is this one not hooked into... I'm not sure how this one isn't hooked into anything. Because all of the... have I got these? I presumably have got one of these hooked into one of the others. But unfortunately, I can no longer tell. I would guess it would be this one, right? Except, can this even... oh, I don't know. Right. I'm going to say that this is fine. We're going to push this live, and I'm going to hope that's going to work. So, off it goes. That's good. Anyway, I've got plenty of money right now, so I should probably spend money on, like, the important things I can spend money on. Because, yeah, I can actually buy new stuff as I do more missions. So, for example, I could buy a random forest. More complex structure than a decision tree. It can recognise more classes. Ah, okay. That does sound useful. So I could buy that. Alternatively, increases sockets processing queue size by 5. Ah, so more stuff can hang around in the queue, or node speeds up by 5%. Very useful. Or alternatively, I can actually buy my cat, who's up on top of the computer there, a Viking helmet. Interesting. Interesting. I should probably buy the additional things, because that's probably useful. In fact, my brand new random forest tool is going to be extremely useful immediately, because 2 of them, together with... Oh, I'm not actually allowed to load balance on this occasion. Fair enough. Yeah, 1 of them in that case, hopefully, will be good enough that thanks to the fact I can now actually get these guys, yeah, split into 3 automatically. Give that a test run. See if that works. And that is going to be nowhere near producing. I mean, it's good, but it's not going to produce anything fast enough. Fine. As it turns out, the random forest is too slow for this task. It just needs to be done with the usual decision tree business. There we go. This should be a nice, simple solution to this, where everything gets fed in the right direction. And yep, just in the nick of time too. Marvellous. Also, by the looks of it, the company I built that tech for is actually losing $3,000 a week, though the users are going up. So it's quite possible I may have slightly over-designed the technology, made it completely incomprehensible, and sunk the business because no one knows how to fix it, and it's vastly inappropriate for the actual state the business is in right now. Oh god, I've become a real developer. You see, I probably should have started with this startup first, because this is the startup that actually popped up first. I just gotta skip to the second one. This looks a lot more manageable to me. So, all you want me to do is just take some squares and then trash the green ones, and then, yeah, as efficiently as possible. In fact, actually, I've got no load balancing, so that's fine. So, yeah, just a really basic double spread here. Yeah, this should be absolutely simple. Just absolutely double check that's actually working as it should do. Yeah, absolutely fine. So, that should be pretty much flawless. I don't really see a way to improve that other than by, you know, making it a tiny bit of a shorter travel distance, because that might make a tiny bit of a change. Yeah, that should be a lot. Fine. Release that. That's much simpler. So, as it turns out, I may have in fact bought too many servers for the self-driving car, because the revenue they've made is $340, and the amount of server costs I've caused them to incur is $26,820. So, I can see how I may have slightly screwed those guys over. The other business, however, doing a lot better. Okay, should be a fairly simple one here. We've just got to, yeah, get a whole bunch of squares over relatively quickly. So if we just divide them... Oh, blimey, the time limit is extreme. Okay, the time limit is really extreme. How am I going to speed that up? I mean, I guess I could just add more load balancing. But then... that's going to get expensive fast. But then again, it doesn't matter if it's expensive in terms of per second, because the whole program only runs for 11 tops. Also, I only just realised you can actually drag and drop and select things, and then copy them and paste them, which is very bloody convenient. Right, well, this should be able to do the process a lot faster, because the load balancers are so quick. And then... oh, still no. How close did we get there? Slow it down a little bit here. Slow it down. In fact, slow it down to really slow at the end. Ooh. Okay. We were only up to... right. I think I must be thinking about this wrong. Probably I need to... well... If I were to load balance enough, the random forest might actually work here, but I'm going to need to add a lot of load balancers to make all that work. Well, I'm very skeptical if this is going to be fast enough, but I'll give it a flipping go. So all of them get spat out. This is at slow speed, by the way. And there's only, yeah, time's gonna run out before they even flipping make it into the things. I wasn't even close that time. That was even slower. I've also just realised something, which is these here, these are the base nodes. There's also custom nodes. Okay, I can see how some of these, especially this one, this one looks to me like it could theoretically have been very useful when I was trying to not bankrupt the self-driving car company. Okay, make it a bit simpler here. 4 into a double decision tree. Ignore the stupid new thing, so the stupid new thing takes too long to do. So that thing's just spitting them out nice and quick. And... okay, it's better than it was. In fact, potentially, if this one just had less travel distance involved, that might actually be good enough. Try it again, because, yeah, if you just basically spit all of them in that direction, and then... wait, what's this one? Oh, I've just got them arranged in the wrong order here. And that's fine. That's... hang the flip on. That was 7 out of... oh, wait, what? Why does the blue fill up... ah, because the blue's receiving the... wait, hang on. There are the same number of blues in circulation, but they're being... well, I guess technically they're being serviced by... oh! I've just had an idea. So because the blues get to follow all routes, they're going through faster. So what if I was to actually change that round and it was to alternate? Okay. Okay. No, this is genius. This is actually, I think this is genius. Because if the blues are getting through faster, because they're the one that's not being represented, then what happens if I were to change that round over here on these ones down here, then logically the other ones would get through faster because they don't get filtered to... does this make sense? Well, I don't know if it makes sense. I don't think it should make sense, but, like, it clearly was the case. The blues were filling up faster. Right, give this a go. See if this actually functions. Because if it's doing what I think it should now do, then they should now start filling up at a more even rate. The blue still... that just did worse. How did that just do worse? It's the same system, just reshuffled. Like, the exact same system, just the other way round, just a moment ago, generated a result where it was almost complete. How... what? Okay, maybe the solution is to needlessly overcomplicate this by adding more duplicate stages in. Now let's see if that actually works any better at this point. Because the problem is it's taking way too long for the materials to be distributed. They're not getting there in time. Now I might be able to improve that just by literally dragging these two processors next to each other, which shouldn't really work, but it might work because they might all kind of get where they're supposed to be going a lot. I think they actually are. Just because I've dragged the processors closer together, that seems to be working better, which doesn't feel like how, like, you know, visual programming should work, because this is just a visual representation, but actually, okay, hang on, I've got a plan. If I literally just drag everything on top of everything else into the middle, so everything is, like, right close together, and thus nothing has any travel time, apart from the travel time right at the end. Let's see if that actually fixes it. Because if it does, then that's wrong, but it's also kind of worked. So if it works, then that logically means it's right. Right, let's see if this gets a better result. Test run. And... I mean, stuff's happening. Is anyone ready to start shipping the final blobs? They actually... okay, it hasn't worked, but it's the best result since the time when I got a good result, and I wasn't quite sure exactly why. Also, I've only just realised you can click on the cat and it goes meow. But you know what, ladies and gentlemen, I think you get the point. This here is Wild True Learn, open brackets, close brackets. And yes, I've had a surprisingly enjoyable time with it. It looks very simple, and yet there's parts of it that do kind of break my brain, because once you get into uneven distribution of stuff coming in, and an equally uneven distribution but in a different way of stuff that needs to come out, and time limits, and all those extra optional pieces I just totally missed and didn't know they existed, yeah, there's a lot of interesting stuff you can do. This is a very early game, by the way. It's in kind of early access, I think, at the minute, so there's a lot of work yet to do with it, but it's a fun little thing. If you enjoyed things like Opus Magnum, you might well like this. So, link in the description below. Maybe we'll see it again when it's a bit further along. I do not know. But in the meantime, I've been John. This has been Many a True Nerd, and this has been While True, Learn. Thank you very much, and goodbye. We've all learnt a valuable lesson here. When people have the zombie plague, don't allow them into confined spaces with you. We should just actually, like, use cannons. Do we have cannons? Use the cannons. Oh, they've got a big hammer. That's what the noise is. And a pirate's just rammed them. Okay, I think we're in a traffic jam on the sea.